Good evening, dear students. Welcome to Gen series. So we are going to see now the pre-weighted questions on symmetrical components now. I hope my voice is clear, right? Okay. Now we're going to see the first question. So this is a GATE question given in GATE 2021. It's for 2 marks. Now the question is very simple. Let's have a look at this question. I'm going to paste the options also here. These are the options. So just have a look at the question. It's a GATE 2021 question given for 2 marks. Suppose IA, IB, IC are set of unbalanced current phasors in a 3-phase system. The phase B zero sequence current given. If phase A current also given and phase C current IC is given, then what is IB in per unit? You know what is given here? IA given, IC given, IB not given. Okay, if you notice here, IC given, right? What is IC? 1 at an angle 120 degrees plus 0.1 per unit. Now, okay, what is IB given? Sorry, IA given 1.1 at an angle 0 degrees. Okay, nothing wrong to say 1.1 per unit. IB not given. What is IB not? 0.1 per unit. But what is asking to calculate is IB. This question is given for 2 marks. But see the options very carefully. The options are given somewhat different. It's not what just a number. Okay. So that's why little careful while answering the question. But how to evaluate this? Because we know that first step, IA naught, IB naught, IC naught are what? Same. The zero sequence currents are what? Same. In all phases. In all phases, the zero sequence currents are same. And we know the formula for IA naught also. You remember IA naught equal to, we can write what? 1 by 3 times IA plus what? IB plus what? IC. All right. 1 by 3 times IA plus IB plus what? IC. Clear? Now, if you try to calculate here, what is IB? See, IA naught, let's substitute. What is IA naught? Is same as what? IB naught, that is 0.1. 0.1 at an angle 0 degrees means what? 0.1. Let's say this is 0.1. That is equal to 1 by 3 times. Yes, I need what? IB. IA is what here? 1.1. IC I am writing first. 1 at an angle 120 degrees plus what? 0.1. You keep as it is. Plus IB also there. Now we need IB. Let's keep IB one side and send the other things on other side. Let's see, 0.3 per unit minus 1.1 minus 0.1 minus 1 at an angle 120 degrees. Yes or not? 1 at an angle 120 degrees. Now from this what you can write? 1.1 minus 0.1 minus 0.3. 0.3 minus 1.2. This is what? 0.3 minus 1.2. Okay. That is 0.9. 0.9 minus 1 at an angle 120 degree is the answer. But that option is not there. Then you have to play with this. How? Let's add 0.1. Let's add 0.1. Okay. And subtract 0.1. The value will remain same. I'm just adding the 0.1. Okay. And subtracting what? 0.1. So the value will remain same. Yes or not? Clear? By the way, this is what? Minus 0.9. I'm sorry. Minus 0.9. Because minus 1.2, 0.3, minus 0.9. So, okay, this same again. You are adding 0.1 and subtracting 0.1. So, what I can write now? I can write 0.1 is as it is. This is what? Minus 0.1 minus 0.9, 1. 1 minus at an angle 120. So, if you take minus common, 1 plus 1 at an angle 120 degrees you can write. What is this 1 plus 1 at an angle 120? 1 at an angle 120 is what? Alpha. I can write this. 1 plus 1 at an angle 120 means, let me write separately. This is 1 plus alpha. 1 plus alpha equal to what? Minus alpha square. Alpha square means what? Minus. Okay. Let's see. What is alpha square? Alpha square is 1 at an angle 240 or 1 at an angle minus 120. 1 at an angle minus 120. Okay. Clear? Now you check. What is the answer? So 0.1 minus 0.1 minus, okay, sorry, minus alpha square, na? 1 plus alpha. This will be replaced with minus into minus plus 1 at an angle what? 240 degrees. Otherwise 1 at an angle minus 120. Let's check the option. The same thing we can write 0.1 plus what? 1 at an angle minus 120. Both are what? Equally valid. So which option is satisfying this? 0.1 plus 1 at an angle 240 is not there. This is not that. This is not true. Yes, this will be true. Okay. Bit typical question. You have to think after this step properly. Okay. Then only you will get the answer clearly. I hope this is clear for you. This is a question given in GATE 21 from symmetrical components. Now, there is a latest question, I can say. Now, there is a one more question. This question also given in GATE 14 from the same topic, symmetrical components. Again given for 2 marks. See the question. It's a GATE 14 question. Can you read the question? Let's think, try this question.
Reasons why you should download.
Okay, if you want to solve this question, simple. Again, you need to use the symmetrical components logic only. See, if you notice here, IA given, IB2 given, IC not given, then asking to calculate IB. See, first of all, what is the formula for IB? The formula for IB is what? I can write like this. Okay, I small b, let's say, fine. IB naught plus IB1 plus IB2. You may also say this is what? In terms of A phase currents, IA naught plus alpha square IA1 plus alpha times IA2. Okay, clear? So the given is IA. IC not given, IB2 given, IA given. See, from IB2 you can calculate IA2. From IC naught I can calculate IA naught. Then IA equal to IA naught plus IA1 plus IA2. Using that relation I can calculate IA2. Then you can substitute here, you will get the answer. So what I am saying is IA naught equal to what? IB naught equal to IC naught. Kada? So using this relation I can write what? IC naught. That is what? 3 at an angle 90 degrees. Good. Now tell me, IB2 given, then I can calculate IA2. What is the relation? IB2 equal to what? Alpha times IA2. From this, IA2 equal to what? IA2 equal to what? Alpha square times what? IB2. That means 1 by alpha is alpha square. So what is this? Alpha square is what? 1 at an angle minus 120. IB2. Otherwise 240 degrees better. 1 at an angle 240. 4 at an angle minus 150. 240 minus 150 is what? 90 degrees. Okay. Clear? So we can write 4 at an angle 90 degrees. 240 minus 150, right? Chalo. Now IB2 you got, IA2 you got. Now tell me what is the formula for IA? IA0 plus IA1 plus IA2, right? Now let's substitute here. IA is given 1 at an angle minus 90. 180 angle minus 90 means what? Minus J1. IA naught we got 3 at an angle 90 means J3. Plus IA1 we need to calculate. IA2 4 at an angle 90 degrees means what? J4. Yes or not? From this what is IA? 2. IA2 is what? J7 minus J1 minus J8. If you send this. So you got IA naught, IA1, IA2. Then what is IB formula? Let's substitute directly from here. IA naught J3, otherwise 3 at an angle 90 plus alpha square means what? 1 at an angle 240 or what? 1 at an angle minus 120. Okay. IA1 is how much? Minus, sorry, this is IA1. Okay, 1 at an angle minus 120 degrees. Otherwise, 1 at an angle 240 degrees only you write. Minus J8 means what? 8 at an angle minus 90 degrees. Plus alpha 1 at an angle 120. IA2 4 at an angle 90. So if you solve this, J3 will be there. 240 minus 90, 150. 8 at an angle 150 degrees. Plus 4 at an angle 90 degrees. 4 at an angle 90 degrees means how to write this? Think about it. 4 at an angle 90 degrees and 120, 210 degrees. Otherwise 4 at an angle minus 150. That's it. If I solve this, imaginary part get cancelled from here. Only we get real part. J3 as it is. What is the real part? 8 cos 150. Here 4 cos 150. So total 12 cos 150. 12 cos 150 is 12 cos 150. Let me try directly. Minus 10.932. So okay. So just try it. What is the answer you get? He's asking magnitude of IB, right? Just think once. 4 at an angle minus 150. So this is correct. Okay, now this will be turns around 11.53. The magnitude will be approximately 11.53. You can verify. The magnitude of the current, right? 10.53 932 whole square plus 9, 3 square will be 9, and root over of that 11.33, approximately 11.33. So the best answer or nearest answer is what? 11.53. So the option is what? C. The magnitude of IB is what? Approximately 11.33. So this question given in GATE 14, again for 2 marks, and there is a question So this question is a general question. I can't say it is a question belongs to symmetrical components. See, this question is given in GATE 2006. A three-phase balanced star-connected voltage source with a frequency omega radians per second is connected to a star-connected balanced load with supply, which is purely inductive. The instantaneous line currents phase to neutral voltages are denoted by IA, IB, IC and VAN, VBN, VCN. All are instantaneous quantities. And their RMS values are denoted by V and I. Okay. So now the question is, what is the magnitude of R? And R is defined with this. R is defined with this. Okay. Clear? Now, let's generally take a balanced star connected voltage source, right? Voltage source is balanced here. Okay, no doubt the voltage source is balanced. VAN means what? Root 2 V sin omega t. This is root 2 V sin omega t minus 120. Root 2 V sin omega t plus 120 here. Yes or not? Clear? And here what? IA, it's a purely inductive load. That's why the current lags the voltage by exactly 90 degrees. Here root 2 V by, so Z. Okay, that V by Z is what? Again RMS current. What is that RMS current? I. So that means I can write root 2 I sin omega t minus 120 sin omega t minus 90. Again this is phase shifted by that. So what I am trying to say, let's write the expression for VAN in terms of RMS voltage. What? V sin omega t, instantaneous voltage. That's why I'm assuming what? R phase voltage is reference, A phase voltage is reference. What about VBN? Better, root 2 V. Root 2 V sin of omega t minus 120. What about IA? Since it's a purely inductive load, the current is what now? I equal to what? For example, IA, VAN by what? JX. Correct or not? Purely inductive load. That's fine. So what do you get now? VAN. VAN is what? Root 2 V by what? X sin omega t now. That J is what? At an angle 90. When it comes to the numerator, it will become what? Minus 90. If you want one more step, VAN by what? X at an angle 90 degrees. So VAN by X. Okay, but root 2 V by X is what? RMS current. What is that? Root 2 V, sorry, root 2 I, root 2 I. V by X is RMS current, that is I sin omega t minus 90. Yes or not? Then root 2 I sin omega t minus 90. IB same, root 2 I sin omega t minus 90 minus 120 degrees. Phase shift root 2I sine omega t minus 90 plus 120 degrees. So these are the currents and voltages. Now you substitute in the matrix and then solve, you will get the answer. Okay, clear? I hope you understand this. Okay, clear? Now there is another question. So you substitute here. I hope you understand now. IA, IB, IC substitute. First you these two matrix you multiply. So what do you get? For example, here if you see 0 into IA, 1 by root 3 into IB minus 1 by root 3 into IC. Then minus 1 by root 3 into IA and plus 1 by root 3 into IC. Okay. So you try like that. Definitely you get the answer. Okay. Right. Now we'll move on to the next question. This question is given in again GATE 2006 for 2 marks. In this question, what is asking? Again, the line voltages for negative sequence, positive sequence given and negative sequence given. See, the identical star connected load resistance of 1 per unit. The load to neutral is isolated. The load neutral is isolated. The symmetrical components of line voltages are given. What is VA B1 given? X at an angle theta 1. This is in per unit. Then VA B2, that means negative sequence line voltage given, X at an angle, sorry, Y at an angle theta 2 per unit given. So what I is asking, the phase to neutral sequence voltages are, that means what? Phase to neutral sequence voltages are VAN 1. What is the phase voltage? Line voltage by root 3, but that is what? In actual form. But in per unit form, by root 3 will not come. Okay. So VAN1 equal to what? See, let me write like this. V phase equal to what? V line by root 3 at an angle what? Minus 30 degrees. This is fine when in absolute form or in actual form, but in per unit form this root 3 factor will not come. So now tell me what is this? X at an angle theta 1 minus 30 means X at an angle theta 1 minus 30. So VA1 equal to what? X at an angle theta 1 minus 30. Similarly, what about VA2? That means V phase 2 is equal to what? V line 2 at an angle what? Plus 30 degrees we get. So that means Y at an angle theta 2 plus 30 degrees. So if you calculate, the option is what? By root 3 will not come. Careful. Generally people will go for option C. Why by root 3 is not there here? Since it is what? Per unit form. This question is given in GATE 2004 again for 2 marks from symmetrical components only. Now let's see here, a 3-phase transmission line supplies delta connected load Z. The conductor C open, the currents in the line is shown IA, IB, IC. The positive sequence current component in line A will be, what is asking? IA1 is asking, right or not? But we have a formula for IA1, right? What is the formula for IA1? 1 by 3 times IA plus what? Alpha times IB plus what? 1 by 3 times IA is what? 10. 10 at an angle 0 means 10. 10 at an angle 180 means minus 10. Here what? Plus 10. Ante. 10. IB is what? Minus 10. So minus 10 alpha. IC 0. Forget it. So if you take 10 common, 10 by 3 times what? 1 minus alpha. What is 1 minus alpha value? Check. 1 minus alpha is what? You remember yesterday class we discussed. Root 3 at an angle minus 30 degrees. So we get 10 by root 3 at an angle minus 30 degrees. That is 5.78. That is the answer. 5.78 at an angle minus 30 degrees. So option is A. There is one more question given from this topic. Again, this is for 2 marks. I am going to paste this question, but I am going to explain how to solve, but you need to solve. Again, this is a 2-mark question. It's given in GATE 2003. EA given, EB given, EC given, and the both neutrals are joined. What is the current here? Tell me. What is asking? The positive sequence component of the load current. That means again IA1 is asking. You know the formula for IA1, but you should know what is IA, you should know what is IB, you should know what is IC. Very simple. IA is what? EA by, this EA is what coming across these two, J2, IB, EB by J3, IC, because both neutrals are joined directly, J4. EA given, EB given, EC given. Let's substitute IA, IB, IC in IA1 equation. 1 by 3 times what? After substituting, you will get the answer. You try. Okay. So that's it. With this, I am concluding today's session. In tomorrow's session, we will see, sequence networks and sequence diagrams and PYQ questions on that. Okay. Thank you. And if you have any doubts, you can feel free to ask me. Yeah. R is not a power, R is not a resistance, R is just a constant is asking to calculate. R is a product between those 3 matrices. GATE aspirant. How can we solve by symmetrical components? I didn't understand your question. So anyway, so I'll stop here. In tomorrow's session, we'll discuss the sequence networks and sequence diagrams. Thank you.